Hey guys, in this new tutorial, we're going to be covering a subject that a lot of people kind of get confused about and ask about. I originally had planned to work on a new environment scene using a film plate, but unfortunately, I'm kind of swamped with freelance work that's coming up, and I won't be able to basically focus on a longer tutorial just yet, so I'm thinking I'm going to have to push that back to next month. But I think this would be a good tutorial to kind of cover since a lot of people also ask about this, and I don't think there is anything in depth out there regarding all the AOVs in Redshift and how to use them. And so we're going to cover pretty much all about AOVs. And so this tutorial is going to be about compositing our beauty, crypto mat, how to get different puzzle mats, custom AOVs, taking it into Photoshop, taking it into Nuke, and just kind of all the different methods you guys could use AOVs for. At least that I know of. I'm sure there's some weird compositing Nuke tricks out there that I've never even heard of. I'm not a compositor, but we'll be looking at some of the more odd AOVs that a lot of people don't really use or know how to use. So like the normal AOV, the object position AOV, deep AOVs. So we'll be looking at all those things and custom AOVs. But so anyways, we've got a basic scene here. This is using the look dev scene that I've shared with everybody. So it's just the HDR, a floor, and we've got a couple different objects here, just some simple objects that we're going to use to give examples of how to break up the AOVs. And our materials, it's enough variation so that we'll have different AOVs to work with, so we can have every kind of possible AOV. So we've got glass, we've got some plastics, we've got metals, we've got volumes with emission inside of them, we've got SSS, and so this will give us a good variation. So if we already rendered out a little example here, and so this is our example scene. And so as you can see, we've got some lights, we've got caustics, we've got a plastic material with a little bit of SSS, single scatter, we've got a jade kind of a material with some subsurface scattering, multiple subsurface scattering. We've got the skin kind of wrinkly texture here, and this also has subsurface multiple scattering. We've got a metal, gold. We've got another metal with some anisotropic specular. And we've got our volume here with emission inside of it. So this should, and we've got GI and all the other stuff, and specular and diffuse. And so this will give us every possible AOV that we can basically make. And the idea is, how do we composite the beauty back together? And actually, let's exaggerate the post effects, because some people have right now we don't have a post effect AOV. It's inside the internal Redshift builds already, but the devs haven't exposed it yet. I don't know if it's going to arrive with 3.0 or what's going to happen with that. But people have asked how to make a post effects AOV, and so I'm going to actually show you guys how to do that. And it's good just subtractive compositing knowledge anyways, so you guys could use this for other purposes, not just for the post effects AOV, since the principles will apply for a lot of other stuff. Let's actually increase our streaks here so we can kind of get them a little bigger. And I don't think we've got any flare. Oh yeah, we do right here. So we'll keep some flare and a little bit of bloom. And I'll basically be showing you guys how to split this out so that we can get the same result and the process behind it. And so to composite all this and come back to the same beauty. And we're going to be using Rec 709. We could use an OCIO profile if we want. I kind of already showed you guys all this stuff with ASYS, so it's not really that important in my last tutorial. So we'll just stick to Rec 709. Keep things a little simple. Yeah. So for our next step, we actually need to make our AOVs. And so there's several ways you could approach this, and I'll kind of briefly cover which AOVs do what. So if we go into our ROP, and so here we've got our render ROP. Let's just move this down. And when you select your render ROP, you'll be given a couple options. To override stuff and all that. But where the AOVs are is in the output section. And so in here, we've got several tabs with different options. We've got our post effects options also. And this basically says if we're going to save to mplay, are we going to bake in the color, the LUTs, stuff like that. This kind of confuses a lot of people, but the idea is basically you don't want to bake in your LUTs or your color curves, so these things, because this is something you'd be editing and compositing. So by default, these are disabled when rendering HDR or batch renders, and that's normal. We actually want that to happen. We've got our denoising tab, and as you guys know, it denoises. Optics actually lets you denoise individual AOVs, so I'll kind of touch on that also. We'll keep that off for now. The gamma, I wouldn't mess with any of this. It bakes in the gamma correctly. The output gamma is no gamma. You could have it use automatic or whatever. I wouldn't really mess with it. You could have it on automatic though, and it'll just read in the color gamma. So like the mplay gamma is 2.2, which is basically Rec 709. Or no, not Rec 709. That's sRGB. And then you can switch to custom and then change it to something else if you need something else. But we're going to just keep it on no gamma. So the file output will be completely linear. AOV processing, this is if we're going to do deep outputs, and right now Redshift only supports a few AOVs with deep. I'm going to cover deep separately, so we'll talk about deep later, since this is a whole different subject, a little more complicated, because this requires an application that can read deep, and to my knowledge only Nuke properly uses deep data. Fusion does not. I'm not 100% sure if the latest version of Fusion does, but I know that they don't do real deep data. They only had like a pseudo deep. So, but yeah, we'll cover deep data later. We've got our AOV tab, and so this is where we're going to make all our AOVs, and then we have our common tab. So if you want to render the AOVs to mplay, right now we're using the Redshift render view, and basically how you want to format them, enable image file output. So if you make a batch render, it's going to save it into your hip render folder, hip name, frame number, and output name, like the AOV or whatever. So diffuse, specular, etc., and then the frame number, EXR. And we have the skip rendered frames, the format options here. So if we're going to be doing multi-layer EXRs, you're going to need EXR, obviously. This won't work with TIFF or JPEG. When doing any kind of compositing tasks, pretty much stick to EXR. Don't use other formats. They're just not able to handle the data or negative number data. And so EXR, go EXR all the way whenever possible. Another thing about that, though, is file sizes. Now, I know that a lot of people, because EXRs contain a lot of data, they can get really massive. So one thing you can do, there's different compression models. Zips, I believe, is the fastest for nuke playback. But there's other compressed formats that are basically lossy in a sense that they're not lossless. But for most purposes, lossy formats are okay. So like Pixar 24 is a higher compression model. So you can think of this like a PNG kind of, where it's lossy but still pretty good. And the file sizes are smaller. I personally prefer Pixar 24. And then you have the DreamWorks AA and AB formats. So DWAA, DWAB. And you can think of these kind of like JPEG. And so if you select one, you'll have the DWA compression level. So 45, you can compress it and it'll give you a smaller file size. But these are lossy. And so technically you lose data. But that data loss isn't that important when it comes to certain AOVs. So you don't have to worry about it so much. You only really have to worry about it when you're using data channel AOVs. So AOVs that deal with data, like motion vectors or Z depth, stuff like that. Because then that little bit of lossiness can lead to inconsistent results when trying to apply Z depth on your render in Nuke or motion vectors. So in general, you want to have as much data as possible when dealing with data-based AOVs, while AOVs for your beauty, it's not as important since the values are basically going mostly 0 to 1, and a couple speculative values might go over beyond 0 to 1. While full data channel AOVs, like Z depth, stuff like that, they have value ranges that go massively to keep accuracy for pixel distances when using Z depth. So just something to keep in mind. I think Pixar 24 for our purposes will be fine. We're not going to need super crazy accuracy for a shot. So Pixar 24 is kind of a good middle ground. Like I said, it's like a PNG. It's lossy, but the quality's still really good. You can still get negative values and all the benefits of EXR, but just a smaller file size. So I prefer to use Pixar 24 for most purposes. The storage format, you could do tiled or scanline. Scanline typically reads faster in Nuke. The multi-layered EXR. So this lets you choose how you want to do it, where your render is either a full multi-layer EXR, where everything is packed into one file, all your AOVs, and you have the no multi-layer. So this means every AOV is going to be separated as its own file. That's I guess you could say this is personal preference. If in Nuke, do you like to shuffle out the channels for each AOV, or do you prefer to load each individual AOV as its own file input? That's up to you. You know, you could approach this many different ways. The multi-part AOV, this, I can't remember what this does actually. I'll have to check up on this. And then, yeah, that's about, that's the in general most important files. So the difference here is if we were to save, this is basically like if we came up here and saved here, the save multi-layer EXR. While if we choose save image, that's like saving only what's displayed. So if we were to save right now as a save image, it would only save this. If we pick save multi-layer, it saves all these AOVs into one file. And that's basically what this is doing, but for your batch renders, when you batch render everything together. Houdini 17.5 added the new PDG top system, and so it lets you actually batch render out some stuff, which is kind of cool. Using, instead of the batch window up here, you could actually use PDG to render out your shot. Right now there is no PDG per frame per GPU option. It's being requested, so hopefully the side effects guys add it. For now, it's not possible to split it. Only Deadline lets you do that. But I'm hoping that very soon in the near future we'll be able to do it with PDG and tops, so that each frame renders separately in the background. And we'll do that in a little while when we animate the camera a little bit, just so we could play around with the animation inside of Nuke later. But for now, we just want to composite this beauty. So how do I make this beauty be our result? And there's several different ways. So let's move over to the AOV section. And the AOVs that we're going to need are basically all the beauty creation AOVs. So for now, we're not going to do per light AOVs. We're going to just do, let's recreate this shot with all the pieces we need. So there's different types of AOVs. So this is something else to keep in mind. We have the diffuse lighting, for example, and then we have diffuse lighting raw, and then we have diffuse filter. And so the way to think of there's a couple of these have the filter option. So refraction filter, reflection filter, diffuse lighting filter, and the GI raw. And so the way to think of the raw and the filter files is these, when you're doing the order of operations, when you're compositing them, is these require you to multiply, while regular, like diffuse, no, not diffuse, the specular lighting or diffuse lighting, these are additive. And so that's how you have to think of it. So there's an order of operations. And actually, let me bring up the Redshift documentation to show you guys this equation. And so if we open up the documentation page, here is the equation to build your beauty. Now, this equation is assuming you're using the filter methods. And so how it works, and I'm going to just copy this actually and open up Notepad or something so I could just type it out for you guys. And actually, let's just do it in Photoshop so I can save this as like a graphic for you guys for later usage. Let's go darker. And the idea, let's use the type. And actually, what is the resolution of this? Let's make this a little bigger. Let's do 2500. Let's just hit enter. Since this is what we wanted to show here. So when you're using the diffuse filter method, all the diffuse filter layers need to be multiplied with the raw layer, the same version. So the diffuse filter needs to be multiplied together with the diffuse lighting raw, and then the diffuse filter needs to get multiplied again with the global illumination, and the diffuse filter needs to get multiplied with the subsurface scattering raw. And so you might be wondering, what is the diffuse filter? And then these get added together after, and then you add all your other regular AOVs. And so what is diffuse filter? And you could think of the diffuse filter as, let's actually make it right now so you guys can see it. The diffuse filter is what in PBR we call albedo. So let's actually render this. And so albedo means the raw pixel texture data without lighting, without shadows, without anything. And so if we switch over to diffuse filter, this is what we get. Right? So this is the pure pixel data without any information regarding specular, any of the other data. This is just the diffuse color, period. Nothing else going on. So if we come over here, like you can look at the Macbeth chart, and you'll notice that these are the raw, pure pixel values, right? So if I roll over this, if you hold control, or actually I think in the newest version you could just go, yeah, there we go, this is even easier. You just go into the pixel mode and you can just sample, and you'll notice that these are just as pure values as possible. So this is white, you can see it right here, pure white. While if I go up to the beauty, you can see that it's actually, with all the shadow and lighting information, that value is now in the 70s, the 0.70 range. And so that's what diffuse filter is. So diffuse filter is essentially the raw data in our scene. And some people prefer to composite using this method, where they will use the diffuse filter, then rebuild the diffuse lighting and all that after. So this is kind of like a more fundamental AOV. But there's also, you could also rebuild your beauty without this step. So you could actually not have to do this, and you could instead just use additive, regular diffuse lighting, regular global illumination, and regular subsurface scattering, not the raw versions with the diffuse filter multiplied. So what do I mean by that? Let's actually rebuild this shot so you guys can see what I mean. And so we're going to rebuild it in both Nuke and Photoshop, since I know a lot of people ask about it. And actually, let's beauty using diffuse filter. And let's move this up. And you could actually do the same thing. Rebuild your beauty again. But no diffuse filter. And so what you actually need is, we'll just delete this. It'll be diffuse lighting. Global illumination, regular, not raw. Subsurface scattering, not raw again. and all the other AOVs, all the different, and actually this is missing the volume AOVs also. But let's actually change the color here. And so these two methods you'll end up with the same a beauty. The difference is one uses diffuse filter and multiplies it with the raw channels and then gets added together, and then you add the rest, or you just add the rest consecutively. And so this method up here using diffuse filter, like I said, is a little more granular. You have a little more control because you're controlling every little minute aspect and then putting it together, while this is just kind of easier and it just works the same way. But you lose a little bit of that control from the diffuse lighting and the diffuse global illumination raw and all that. But you know, this will depend on your scene and your needs. Personally, I use this method most of the time when it's fast. It's just faster. If you need more control, I'll switch over to this. So let's move that out of the way. And so we're actually going to do the easier method, and then we'll compare the two. But so okay, let's start making our AOVs. So we're going to start off with just diffuse lighting. Then we also, and let's actually go to our beauty. We also need specular lighting. We need our subsurface scatter. We need our reflections. We need our refractions. Let's just add a few of them. Next step, we need, I don't think we have an emission object, so let's add one real quick now that I just realized that. Let's let's go up to the object level. Let's move this out of the way. Did not realize I was missing an emissive object. So let's make a torus. A little donut. And we'll just rotate it a little bit. Let's come in here. Oops, that's the volume. Our torus. And it's a polygon mesh. That's fine. Let's give it some normals. And let's go to our material. And we could either drop an incandescent, or we could use the RS material and just activate emission. We're going to just use the incandescent for now. Let's drag it on there. And let's just do a temperature. Let's do a temperature of like, I don't know, 7,200. That should be cool. And let's test that out real quick. Let's just see what it looks like. I don't want it to be too intense. Yeah, now it's too intense. And Yeah, that's fine. Whatever. It's being directly lit. So maybe actually let's move it to the side so we can get some nicer GI going on. Oops. What happened? Let's move in world space. Let's move it there. And let's bring it a little closer to the ground. Okay, so there we go. We've got our glowing donut, and it's leaving some GI and stuff. Okay, and let's actually save our scene. So now we've got an emissive object. I knew I forgot something. So let's go back to our ROP, and let's add emission. So that'll capture this. Global illumination. And we need another couple AOVs. We need our caustics. And we can't see them right now because we did IPR. But in bucket mode, they'll show up. We don't have any ambient occlusion. We do have shadows, but this is a totally separate thing that I'll have to explain later. Right now we're just rebuilding the beauty, and this isn't for rebuilding the beauty. Bump, matte, volume. We need these volume now. So volume lighting, volume fog tint, and volume fog emission. Let's add a couple more. I think that's everything, but let me just make sure. Translucency would be if we had a translucent, like a paper or something, like a paper or a leaf, paper thin object. We don't have any. It's not really that important for most purposes. You don't really need it. And the rest of these are data related. So we have our custom, the background. We don't have a background, but I will show you guys what this does. The background is what you need if you have an HDR in the background and you want to save the HDR as its own AOV or backplate. So I'll show you guys that later. And CryptoMat and all the others. Yeah, the rest are just data related, and I'll have to cover those separately. So, okay. So if we actually make a render now, and let's save this. And I have the samples a little bit high. I wanted, to kind of make a decently clean image in 720p. And everything looks good so far. So let's just scroll through here. We've got our diffuse. Notice how this is very different from the diffuse filter. Diffuse filter gave us just the flat colors. This is diffuse with shadow and light information added to it. And so that's what happens here in the filter version. You're adding back in the lighting and GI data onto the flat image, while this, just the regular diffuse lighting AOV, keeps that data already. It already does it for you. And so if you don't need that level of control, then this is perfect. You know, this is enough. Our specular, our SSS, our reflections, our refraction, and there's a little bit of refraction on this plastic, even though in the beauty it didn't look like it, because I am using the transmission. So there's a little bit of refraction in here with a single scatter, just so you guys know. So if you guys use transmission and stuff like that, keep that in mind, that you still need the refraction AOV. Here's our emission, our GI, our caustics, our volume, and actually we don't have any volume fog in our, oh actually no, yeah we do. We zoom in here, you can see it, and it's super subtle. This is a really simple minor kind of an effect, but it does make a little bit of a difference. It doesn't make much of a difference for this specific volume here, but you always want to have that the volume, what was it called, the volume fog tint and the volume fog emission. And the volume fog tint is kind of like a darkening effect, and we didn't actually need these diffuse lighting, so we'll use filter next so I can show you the difference. Here's our fog emission, so you can see that this is the actual volume itself, and this is the light, the glowing emission from the volume, and that's about it. And so something else to keep in mind is each of these AOVs that you see here, they have their own options. So if we come in under common, you can give it a different file name prefix, the data type. You could change the bit depth. Half float is typically good enough. For Z depth and stuff like that, you want full float. That'll make it higher quality. You can change the compression type. Like I mentioned earlier, guys, in general, Pixar 24 works good. For some data, you're not going to want to use that, but I'll go over that later when we actually use data channels. Then down here, you can apply color processing. So this is if you were essentially using photographic exposure and stuff, you want to use that. If you're trying to do the photographic exposure effects later on using a tone mapping inside of your compositor, then leave this off. And then the denoise tag activates denoising if you were using optics. And then the light groups, I'll cover all this separately since light groups are their own thing. And so we'll go over that later. If we quickly scroll through here, let's just find a noisy AOV that we could denoise. They all look pretty decent. GI maybe could, how's the SSS? Let's denoise the SSS. I think this could get a little, actually no, the specular looks okay too. You know what? We'll denoise the specular to smoothen out these hot spots. And so let's actually look for a specular. Under material, we're going to check off denoise. And under the denoiser, we're going to activate optics. And there's this checkbox, denoise AOVs. Make sure this is being made. And so if we actually save this, and you guys can see, there's a little bit of speckling here and there. We'll see how it looks with a new version. So let's render this. I'm going to pause the video so you guys don't have to wait. Alright guys, so we're back. Here's our denoised beauty. And you could just switch to the noisy version, and you can see that we've got those little speckles there. And now if we look at our specular, it smoothened out those little hot spots in some areas. So this is pretty useful if you want to denoise just a specific AOV that's giving you trouble, and that way you don't lose detail overall, because most of your other AOVs, when you composite everything, are still sharp and not really going to have issues with optics. So I find that, you know, really a really useful feature. I use optics all the time on specific AOVs where, you know, we're having issues that it's not worth firing more samples. So anyways, here we've got our render and it's ready to go, right? So now all we've got to do is we could save it out as a multi-layer EXR, and I'll show you guys how to work on this inside of Photoshop instead of, and then we'll move on to Nuke actually, but Photoshop first, since a lot of people I have asked me about how to do all this stuff with Photoshop because they're not using Nuke, and they only work on still images. So this is good information here. So let's save out our multi-layer EXR. So let's just save this out. I've already got an older one here, so I'm going to just replace it. And we're going to rebuild this beauty using all these AOVs we just made inside of Photoshop. And then I'll show you guys the same thing, but we're going to do it in Nuke. And we'll also do the filter method. And then after that, we'll move on to some of the, or actually we'll move on to per light AOVs. And then we'll move on to the data AOVs. So let's fire up Photoshop and open that up. So here we've got Photoshop open. And just so you guys know, use the EXR.io plugin. Highly recommend it. And we're going to split the alpha out so that each of our AOVs has its own separate alpha pass, so that it's not pre-multiplied, it's unmultiplied. So let's open this up, give this a second, and you'll see that we've got all these A channels. We're going to get rid of these because we don't need them. We didn't actually make any alphas. And we'll delete that. And so here we've got our beauty. And you might be wondering why it looks a little different than the IPR version. And the reason is because this is being viewed in Rec 709. So if we switch to sRGB, it looks the same. And that's because I don't have Rec 709 being read in here inside of Photoshop. So anyways, let's make this a little bigger. So the goal is to make this beauty using just these layers we've got here. And so the great thing is that since this is the easy method, you don't really have to do much. We're going to just drag down our diffuse RGB to the bottom. And all you have to do is just make all of these operations linear dodge add one by one, or just throw them all into a folder. Actually, no, that won't work. So you got to manually make each one of these linear dodge add. So we're going to switch that over. And this, actually, this emission tint, even though it doesn't say emission tint here, this actually can't just be done a linear dodge add to the, oh, actually, no, this is, here it is, the fog tint. This layer, unfortunately, is just like the diffuse filter layers. You have to actually multiply this first before adding it in. So if we come back and refer to the documentation here, you'll notice it says we've got our volume lighting, which is where is it? Volume down here is. So let's put them all together. And here's this is regular emission. We need fog emission. And if we refer back to the documentation here, you'll notice these 3 AOVs are needed to recreate any volumetric effects exactly like the beauty. But one of these layers is special, and that's the volume fog tint. Here it's just called fog for some reason. There's no tint in the name. And you'll notice right here it says volume fog tint AOV is a multiplicative layer. So just like I was describing earlier, the diffuse filter having to get multiplied with the GI raw and all the other raw AOVs, same thing kind of has to happen here. And so if you notice here, it'll say the volume fog tint can be thought of as a global volume transmittance, and it serves to dim the scene accordingly before the volume lighting and volume fog emission AOVs are added. See? So this actually has to be multiplied onto our shot, and then you add all the other stuff. So if you think about it in that order of operations, here in Nuke you got a node, but the layers here are a layer stack, and so you start with the bottom and then you work your way up, right? So what does that mean? Since the order, like this says, has to happen first, accordingly before all the other stuff, this needs to come down all the way to the bottom, right after our diffuse, or at least before we add our fog emission and volume. I'll just put it down here because I think that's a good spot to keep it at, since we are going to only make the rest additive, and this one needs to be multiplicative. So actually, let's hide all these so you guys can see one by one what's going to happen. So here's our diffuse, our fog. We're going to make this multiplicative. So multiply. And you'll notice that it darkened that area, just like the documentation said it would. So let's move that out of the way. And now we're going to add our SSS. So this needs to be linear dodge add, which is additive. We're going to activate now our specular, additive. And you'll notice piece by piece, it starts to rebuild our original beauty. See? Which is great. And so now we have exactly our beauty render. Let's open up this here and we'll go to sRGB, and you'll notice they are identical, except for we're missing our post effects, right? You'll see the glows and stuff like that, but everything else is already there, right? And so what does that mean for us as a Photoshop user or something? This means that you could adjust all these things to do whatever you want, really. I mean, change this to a different color. You can make our refraction, for example, if we added an adjustment layer to our refraction, let's just do I don't know, hue saturation, and we'll clip it to our refraction, and we'll actually make a mask so that it only influences our, actually let's make that our little gem looking thing. And actually let's do that, and let's invert it. Why is it not inverting? There we go. And so if we were to adjust our hue here, and something weird's going on here. Not entirely sure what that is. Huh. Well, in theory, it should, I mean, it is adjusting it, but I'm not sure what this streak of intense color is. But it's likely because of all the other, we'd have to influence all the other AOVs individually. And so usually this is why you use matting or masks on individual objects to do that across everything as an adjustment on top of the entire thing rather than each individual but AOV. But this lets you at least somewhat adjust that effect. So like, let's say the caustics, they're too weak or something, you could just be like, oh, let's increase the exposure on them. You know, obviously that's too much, but, or we can make them weaker. Or let's say they're a little noisy or something, or you want to blur them, you could just blur them. And soften them up. You know, just a bunch of options, right? So that's that. Now, the problem with post effects, getting post effects in here. And so the problem is a few things. When you composite the beauty like this, you will have issues because the beauty here in our render is using the photographic exposure. So let's actually, and all the post effects, right? So this tone mapping stage here is not possible on each individual AOV. You just can't do it. It doesn't work. And so there's two ways kind of around this. You could either A, subtractively recomposite that look back in as like a post kind of a thing, or you can do it using the tool that I made for Nuke with the help of Adrian, which kind of gives you the same exact algorithm for the photographic exposure. Or you could just, you know, in comp, not even deal with it, right? And so if you wanted to, let's just drop down, I don't know, some levels or something. You know, you could do it yourself using curves and whatnot, right? But let's say you wanted the exact same thing. Or let's say you wanted the exact same look. So if we look at our RGB, you'll notice it's darker because of that tone mapping going on here due to the photographic exposure. And you'll also notice that our post effects are here. So how do we get this as its own separate AOV? And And like I mentioned, guys, we don't have that AOV yet, but there's a way to do it. And so we just have to use subtractive compositing. So if you select all this that we use to make our beauty, and we duplicate it, and we merge everything into one layer, and we move that layer on top of our beauty layer, and then we make this into subtractive, or subtract, this will subtract between the two, and this is the leftover data, which you can see our post effects and the tone mapping and color changes are in there. So now if you merge these two layers and you make this linear dodge add, now it's its own AOV. See that? And you could adjust it. Now the problem is this is still keeping the tone map. It's baking in the tone mapping. So you might not want that. So in order to avoid that, the only way around that, basically, so you only get the bloom, glare, flare, is when you render this out and save it, you have to disable photographic exposure. That's the only way. Because this tone mapping gets baked in. So right now, if you compare the two, they're identical, even with the post effects. So let's just disable that, for example, and save it again. And we'll just edit this to no photographic exposure. We'll save that. Right? And we'll move that to the side. And let's actually load that up. And we only need this layer. So we'll cut that out. Paste it in here. Close that. And we'll do the same process. So we'll delete this. We'll duplicate this again. Merge everything. And this is with and without. And actually, now that I look at it, our AOVs do have some tone mapping applied. And the reason, if we go back to Houdini here, is down here, like I mentioned, the apply color processing is active. So you would have to disable this on everything, all your AOVs. But the same principle will apply. If we activate this, we move this up, make this subtract, we merge the two, and we make this additive. We've got our post effect glow and all that stuff. And even the tone mapping and whatnot. So that's how you guys can separate the post effects in Photoshop. And the same process will be possible in Nuke. You're just subtracting the composited beauty with the beauty render, and whatever's left over is what's added back on, which would be the post effects and stuff. So let's do an example of that right now. So we'd actually well, we'd have to re-render it, so I'm not going to bother. And what just happened that it's white. Oh, this needs to be normal. Linear dodge. And this needs to be multiply. And the rest can be linear dodge add. So, cool. And that's how you work with that inside of Photoshop. So, let's say we now want to do the same, but with the diffuse filter method. So all we got to do is come down here. We're going to switch over to diffuse lighting raw, subsurface scatter raw. Let's make a few more. The reflections raw and filter, and so on. Yeah. Well, yeah, we'll just add those. Might as well. Let's just get it over with. Raw. The refractions raw. Actually, no, we don't need the refraction. Well, if we wanted to split everything, but we could just use only a few. So we'll just do, we don't have to go through all of them. That's going to take longer. We'll just do GI, subsurface scatter, and the diffuse lighting separate like this. Or not even this. We'll just do the diffuse lighting and the GI just to save time. Because it's the same process, just we're just repeating it, and it'll take longer to explain all that. And we still have a whole bunch of other stuff to cover. And let's expand everything real quick. And we're going to disable apply color processing so we don't have to deal with that later. So let's go through here. So that none of the AOVs have any photographic exposure influence. Well, actually, no, it doesn't matter if we just disable it in the render view. That'll work too. This would you only have to do this if we're going to do a batch render, and we're not going to do that right now. So let's just, for now, I'll keep it on. All right, so we've got everything in here. Let's do another render. And we're just going to save it without the photographic exposure. So pause this, and I'll show you guys how to composite the filter method, and then at the end we'll move this actually over to Nuke next. All right, the render's done. Let's go back into Photoshop. Let's open up our no photographic expo. Oops, and I did not save it as a multi-layer. Let's do that again. And let's reopen this. Update. Alright, so let's just get rid of all the alphas we don't need. And you know they're alphas because they have .a at the end. That's how you can tell that they're alphas. And we'll delete this. And yeah, we'll just repeat the process real quick so you guys can kind of review what we did here. So all we got to do is, here's our beauty. We'll get rid of the noisy beauty. And we've got all our files. All we have to do is move our fog down to the bottom, and then our diffuse RGB beneath that. Make our fog multiply. Select all our other AOVs. Make these linear dodge add. And actually something else is going on here. Oh, that's because I have the raw AOVs. I forgot about these. So let's disable those because we'll go over that next. So, and something else is going on. Where is that coming from? Huh. So it appears that our fog AOV has a bug. and I'm not entirely sure why these are happening, but you know, whatever, we'll just delete it for now, and I'll look into it later. Might have to report that. Yeah, there's something definitely strange going on, and it might be due to using diffuse filter that's causing this, which is strange. So actually, let me save two versions of this. So I'll just call this filter, because it might be interacting with the diffuse filter and not work with the regular diffuse down here. So, but that is strange. That's like a weird artifact, but I'm gonna check that right now. So I'm gonna re-render it without the diffuse filter and see if it came back to normal. Alright, so I'm back. It appears to be maybe a bug, because now it's fine. So I'm gonna look into that later and report it if I need to. So, and I'll save two different Photoshop versions for you guys, one using the diffuse filter method and one without. And in fact, let me split the diffuse filter methods down here. And actually, I'm missing the diffuse filter, so let's open up Houdini, move up to diffuse filter, and we'll just save this individually. We'll call this diffuse filter AOV. And we won't even bother to load it in, since we're going to save this as a separate one. So this is without diffuse filter, and I'll probably rename the file. And yeah, actually, let's just, oh no, we'll keep it for now, so we don't have to reorganize everything. And here's the raw. We'll move this down, and there should be, oh, here's the GI raw. Okay, so now the rest of these, we could activate them, and there we go. So this should look like our beauty, except for the post effects. Yep. Yeah, looks the same. And actually, no, there we go. So I could see those boxes again. See that? So it appears that something went wrong with the when using the filter method. That's really weird. Trying to narrow down where that's coming from. It appears to be just the diffuse itself is what's causing that. So let's check that out. I'm not seeing it here. So if I hide all this, yeah, I think the render just had a bug, because this is not right. And then if we look at it here, yeah, we don't see that box. So yeah, it's just the diffuse layer got busted somehow. I don't know. Things happen, you know. So I'm going to just resave it out as its own pass. Word of advice, guys. Make sure to check on a single frame before you batch render. Otherwise, you know, it would have sucked if you left this rendering overnight and you wake up to find that weird artifact. So let's bring that back in. Let's load this up. Let's select all this, and actually let's make sure Yeah, that box isn't there anymore. So yeah, it was just a bug in that specific render for some reason. So let's copy the name. We'll throw that away. And actually, now I think this will even work. Oh no. So it's a combination of these were messed up. See, now it's working fine. So okay, it's pretty weird. And let me check. Yeah, it appears that everything rendered bad. Yeah, you can see it here too. So unfortunately, it looks like I have to re-render everything again, because all the AOVs for some reason got these weird boxes in them. So I'm going to pause this for a second, and I'm just going to replace them so you guys don't have to wait around. All right, we're back, and everything looks back to normal. Yeah, it was just a bad render, so I re-rendered. Everything's fine now, and we'll just duplicate. As you can see, now we only have no photographic exposure, only the post effects bloom and glare. So all we got to do is duplicate this, merge these layers, so we have one with post effects, one without, and after that, and actually let me duplicate this again. We'll just call this beauty so I don't delete it, since I'm going to merge them. We'll hide it for now, and we're going to move this, the no post effects version on top. Then we're going to switch over to subtract, and you'll notice that that's all that's showing. The post effects bloom, the glare, stuff like that. Then we're going to merge the two, and now put that into linear dodge add, and there we go. We've officially, if I activate the beauty, there is 0 difference. So now we have an AOV with the post effects. And, you guys could lower the opacity or whatever, right? You can tweak the exposure. I mean, that's too much, but... and make the post effects even stronger, weaker, and so on. Cool. So this is how you composite the beauty inside of Photoshop. Everything using the method without diffuse filter. So the only one you got to worry about is the fog tint. And I'll actually rename this fog tint, because it's, so you guys know, that's the AOV I'm talking about. This one has to be multiply, and it has to come before the rest. Everything else can be additive. And I just showed you guys how to get the post effects using subtractive compositing. Cool. So how do we use these methods instead of using just the regular diffuse? How do we use the diffuse filter? And so I'll show you guys how to do that next. But I'm going to save this file so you guys can check this out. The non-diffuse filter method. And then we'll move on to the diffuse filter method right now. Alright guys, so I saved the scene. So there's, when you guys get it, the zip file will contain the non-diffuse, and then this is the diffuse filter method. So how do we do the same thing but with diffuse filter? So for starters, everything else is the same. The same way we got the post effects, all these other ones, it's all the same. These all just have to be linear dodge additive. And the fog tint obviously has to be multiplicative. Now, we're going to get rid of diffuse though. So we're going to delete that. And we're going to use, let's just hide all these. And we're going to use diffuse filter. So how does this work? We have to have diffuse filter because this is the most important. This comes first before everything else. So we're going to drop this down. And if you look at the equation, it says diffuse filter multiplied by the raw first. And so order of operations, guys, you know, basic math, you have to multiply first, then add. So, and then it says diffuse filter and then global illumination multiplied, and then you would add it to the other two that got multiplied. So what does that mean? We need a diffuse filter for every raw pass. So we have one right now, but we have 2 raws. So let's make 2. And let's move that up. And we'll just hide it for now. So we have our GI raw. So these 2 need to get multiplied. So we're going to come up to multiply. And there is our GI raw. Now, if you were to compare the two, in a way, let's put these in their own folder, because they're going to need to be in their own folder. So we'll call this GI raw, and we'll just change the color to red. If you compare this to the GI normal, you'll notice they're the same. See that? So when this is creating this AOV, it's just more fundamental. Like I told you guys earlier, this is at a lower level, but the result of multiplying the diffuse filter and the GI, any raw, is one of these AOVs, right? So we're actually not going to use the GI anymore. So let's just throw it away. And we're not going to use, we already threw away the diffuse lighting. So for our next step, we need to make that diffuse lighting. So how do we do that? We have our diffuse filter again and our diffuse raw right here. Our diffuse lighting raw, I should say. And this has no color data really. So what we got to do is again multiply. And lo and behold, it's just like our diffuse lighting regular AOV we had earlier. And we're going to merge these two together. We'll make this orange. Or let's make it another color, green. And we'll call this diffuse raw. And so that's what's happening, guys. The raws get multiplied together with the filters, with the diffuse filter, and they basically create one of these regular AOVs that we had earlier. And so now these two just have to be added on top of each other, just like order of operations, like we were talking about earlier, guys, right here. So we add to the other raw. So all you got to do is switch that over to linear dodge add, and now we have our GI and our diffuse put together. And then the rest we could just do like we had earlier. Multiply, turn all these on, and we're back to square one. Same result. So now you guys can see what the raw and filter method does. It lets you, it's the fundamental AOVs for the rest to generate some of these other AOVs. It's like the way that those are made. Like I said, not everyone needs that level of control. I usually don't. So I prefer the easier just add everything together method most of the time. And yeah, now you guys get it. See, beauty, same, 100% the same. So we're going to just save this. And now we're going to move on to Nuke. So you guys can see the same process, but inside of Nuke. All right. Hey guys, before we end up moving on to Nuke, I actually wanted to real quick just do a little animation so we can get 10 frames to use inside of Nuke. And so we just got the camera moving around, a null object, and one of our objects is rotating. And we'll just use this for motion vectors. And I also wanted to show you guys how to use the new PDG top system to render out a batch render that is going on behind the scenes. So if you come up to your object level and you decide, okay, I'm happy with what I got, you know, 10 frames, whatever, and I want to render this out using tops, you just hit top, drop down to top net, and this, everything else is fine in here. It's just going to use your project name and stuff like that, and you'll have your local scheduler, and this is by default fine. The only thing you want to keep in mind is right now Tops is designed to work for CPUs, not GPUs, and so and this is something that's being requested, so hopefully Side Effects adds this feature. But for now, if I were to render with this, it will lock up the Houdini and Redshift render, because it's going to assume you're rendering with CPUs. And so I'm on 40 threads, and so it's going to try to render 40 frames at once. And obviously your GPUs can't do that. And so you can't split one GPU per job just yet. So the closest way to get around that limitation is to go into your local scheduler. And you could do this with Deadline too, but I'm just going to show you guys how to do it without Deadline. So this is just using your local scheduler inside of Houdini. And under the job parameters, you're going to click single. Actually, not single. CPUs per task. There we go. And so all you want to do here is use the same amount of GPU number you have. So I'm going to just say 3. The reason this will work is because it's going to limit to render only 3 frames. And since I'm going to only be using 3 GPUs, if we come up to my plugin options, I've got my display GPU disabled. So we're only going to render on 3 GPUs at once, right? And so now if we just drop down a ROP network, I believe. Oh wait, no, not a ROP net. What was it called? Where is it at? Scheduler. Tractor Deadline, yeah. And just so you guys know, if you guys have an HQ server, you can do it that way. You can do it with Deadline. ROP fetch. I believe this is what we need here. Yeah. Yeah, ROP fetch. And so what this will let you do is if we point our ROP path. So select this and we look for our Redshift ROP under out, and we have the IPR ROP, even though this is the render ROP, it's named IPR ROP. And we select that. And so how this is going to work is you could either do a single frame or a frame range. We want it to evaluate 1 frame per CPU task. So this should work now. And where it's going to save your files, and the scheduler, you want to use the scheduler we're using, which is local scheduler. And so right now, if we go to out, let's make sure we've got everything set correctly so that we can write out our files. We did want multi-layer EXRs like we had earlier. And actually, let's add a few AOVs so I don't have to re-render this multiple times. We're going to just add all the extra AOVs we need, and I'll talk about them individually once we get to it. But let's add Z depth. Let's add motion vectors. Actually, you know what? It's only a couple frames. I'll just use the motion vectors for now, since we're going to get a little bit of movement. And the other ones I can explain as stills, so that's not a problem. So let's actually do that. And for motion vectors, we're going to want output raw vectors. Make sure this is activated. This is what we want. A lot of people have issues with motion vectors, and the reason is you want this. You want the raw, pure values. And let's activate motion blur and deformation motion blur. None of these settings matter when you're using the motion vectors. They're irrelevant. And yeah, cool. This should be saving out into our render and using our frame number and so on. So all we got to do now is go to our top net, and you just got to hit, I believe it was Shift D, or is it Control D or Alt D? Or what? There's a hotkey, I can't remember right now actually what it is. It's oh, Shift G. Shift D is, I think, cancel. So Shift G. So if we hit Shift G, and actually it's processing only one frame, which we don't want. So let's hit Shift D, come up here, and frame range. So 1 through 10. Okay, so I did need frame range active, and that should work this time. So let's hit Shift G, save our scene, and there you go. You'll notice that these little green dots are our 10 frames. So 3 frames are rendering out of 10, and 7 are still unfinished. So we zoom in here, you guys can see that. So 3 frames are rendering at once. So if I actually show you guys the folder, let's come in here. You'll notice inside of render that there we go. We've got 3 renders going on at the same time. 1 already finished, 1 frame. Or actually, no, this is the frame we made earlier using just Photoshop for Photoshop. So I'll let these ride out. And actually, the settings are pretty high, so it might take a little while. So I'm going to pause this, but this is how you're able to render in the background using tops and PDG. So you could keep working and do whatever you got to do, model, stuff like that. All the while, tops is rendering in the background. So this is pretty useful for batch rendering, so you don't have to open up mplay or do any of that stuff. This kind of just cooks in the background. And yeah, so I'm going to let this go for a couple minutes, and I'm going to pause it, and then we're going to take these frames inside of Nuke, and I'll show you guys how to composite them like we did in Photoshop, and then we'll move on to using motion vectors. And then from there, we'll go one by one, breaking down all the other AOV types. So I'll be right back. Alright guys, so our PDG render has finished. It wasn't liking 3 CPUs. I'm guessing it's because this was kind of CPU intensive, since I had to do the caustic cache and stuff. So I just dropped it down to 2 or 1, and it just worked perfectly. I don't know if it's a bug with PDG in this specific scene though. So yeah, everything rendered out, and we've got our frames over here. So they're inside of our render path in our Houdini project, and we're going to just bring these into Nuke. So let's just go ahead and let's move Houdini for now and expand our Nuke project here. And so here we've got our viewer, and we're going to load in our asset. So we're going to drag in frame 1, and we're going to just replace the 0001 with just the number, or hashtag as people call it now, and that will load our frames. And we only have 10 frames, I believe. And actually, let's hit the 1 key here. And it's only 720p. And why is it not? Oh, here we go. Frame range. What's going on? There. And we don't have anything else after frame 10, so we're going to just make our project only 10 frames. So here we go. And that's our render. And so we've got our spinning object, we've got our caustics and our flare and stuff like that moving around and all that. So how can we split this data up? If we come in here, you'll notice we've got all these channels. And all the layers. So we've got our velocity, caustics, diffuse, diffuse raw, emission, and other stuff that we aren't really using, which is under there. And we've got our, thought we had our diffuse filter, but I'm not seeing it. Yeah, I believe we're missing the diffuse filter. So I'll have to re-render this, but for now I'm going to show you guys how to composite it just using the additive method that doesn't use the raw and filter method. So we'll work with that first. Let's come back up to RGB and let's switch on over to Rec 709 since that's the view we were using in Houdini. And what we need to do is shuffle out all these layers into their own layers. So drop down to shuffle, and you could use a shuffle copy or just shuffle. We're going to be doing a shuffle copy so we can split it and duplicate basically the input that the input layers that are in here. And actually no, it's a regular shuffle. We're not copying from a separate thing. So we're going to just do a regular shuffle, and then from here we're going to extract out each one of our AOVs. So if we click on our in one, we've got our AOVs in here, and so we just need to get one by one. So we'll get diffuse, and we'll just split this out as RGBA. We'll call this diffuse, and we'll just copy, paste, plug that in, and we'll just paste, paste this a few times. Just so I can make sure that we got enough. So for here, we're going to get our caustics. For this layer, we're going to get our emission. For this layer, we're going to grab our fog. For this layer, we'll get the fog emission. For this layer, we'll get GI. And oops. Let's move this down. Let's copy this, paste it a few more times. Let's connect this in. We'll call this reflection. And what's going on here? Oh, it's not plugged in. Use the refraction. Specular. Let's paste again. SSS. And volume. And I believe that's it. I haven't done the velocity since we'll talk about that separately. Right now we're going to just talk about how to composite all this together. So now that we've got everything, it's pretty straightforward actually. We just need to drop down a merge. And we're going to just merge everything together. So let's move everything. And actually I need to check which one of the volume. I think it's fog. Yeah, fog. So this one needs to be a multiply. So this one's going to be special. So we're going to move this out of the way. Select all these. It's probably a better idea if we do them side by side. In case I, wanted to add more nodes or anything like that to it. And so what needs to happen is first we need to merge our fog on top of our diffuse. And this needs to be done using multiply. Just like in Photoshop, we multiplied it over. And so let's see what our result is. And you'll notice that it's dimming that region. You see? It adds that darkness. And so now all we got to do, now that that's been done, is make another merge. And we'll select that, make our merge in with our original merge. And then we've got to just add all of these on top. And they should be plus, which I believe is additive, but let's see here. Let's just put them all together first. And actually, no, I think over is fine. Yeah, over will work. So, and there we go. So if we now compare this, let's hit 2 with the original here. And actually we're missing the post effects. So if you look at this frame, for example, you'll notice that our beauty versus our composite, that's what's missing, the post effects. So how do we get this back, right? So it's the same idea as we had earlier. In Photoshop, you just have to subtract the post effects out using negative compositing, or subtractive compositing, I mean. So we got to drop down another merge, and we're going to merge in our beauty using all these AOVs, but we're also going to merge in our original beauty with the post effects. And actually, let me drop down a little point somewhere. There we go. And I'll probably split these to the side too, just for organization. Actually, that one doesn't need it. All right, cool. And we could, organize things a little nicer and stuff if we want. So if we come back here, you'll notice that we've got our merge, but it's an over. We don't want that. What we want is subtractive. Where is it? Screen under max minimum minus. Yes, so it should be minus. The terms are different. In different programs, we'll call it different things, but just think of it in math terms. And this should, and actually I think I have to reverse that. There we go. So this should work. It's just I have to reverse the order of input. So if you hold Shift and X, it flipped it from A to B. See that? And now the post effects is its own layer. And so that's what's going on here. So you can look at this as the post effects alone. And now we got to merge. Or actually we could shuffle it in as its own AOV if we want. No, yeah, we'll keep it like this. Since we don't have to make it into its own channel, it could just add on top. So from here, we will connect back our original. So if you look at this, this is our original, and this is our post effects. And all we got to do is add that back on top. And now we've got our post effects as its own AOV. And let's remove that. And so if we zoom in here and you disable that post, and of course we could edit this further, do whatever we want. So if we disable both of these nodes, or actually do that, this is without post effects, this is with post effects. It's its own AOV right here. So we could, if you want, edit this further, add a grade node after this. So if we hit G and multiply it or something, and you look back at the composite, you could adjust the post effects to your liking. Neat. So yeah, that's how simple it is to rebuild your beauty here. Using Nuke. So now we've got everything back together again. And we've got our all these individual channels that we could edit separately. So if the specular is too strong or whatever, you could, you can tone it down. Clamping the value a bit, or you could shift the hue. So now it's like a warmer color. And so on. And if we wanted to match the photographic exposure, that's what the redshift node is for. And actually I need to load that. So all plugins update. RS photographic exposure. You guys can find this in my Patreon. I actually need to release this still since I have to edit it, and I have not. And so if we drop that in here, it's using all the basic photographic exposure settings that we have in Redshift. The allowed overexposure, the black crush, vignetting, the f-stop, and actually should disable the metadata. And you can see that that's what that does. There's also the modified one, which I made. That's the original, actually. What was it called? The Redshift tone mappers. So there we go. This one has different tone mapping methods. So it's got filmic, Redshift photographic, moto style, or corona highlight compression. So here's the filmic curves that you guys could use to increase or decrease the toe, the shoulder, and so on. And so I'll include this for you guys in the file, just so you guys don't have to look for it on my Patreon. Yeah. So anyways, cool. Now we've got everything composited. The process is the same. If we were going to use the filter method, we would just be multiplying like we did the fog, but we'd be doing that up here, connecting into this multiply several, like this, instead of diffuse here, it would be diffuse filter, and then we'd be adding the fog, the GI raw, and all the raws, and multiplying, and then that would connect down here into all our other nodes. So let's actually save this, and let's move on to adding the motion vectors. So we've got and I'm going to use the photographic exposure method. Let's turn that off. Let's use a value of 0.8. 3 on the vignette. That's cool. And so we need motion vectors to get the motion blur of the camera moving, but also of our object rotating. And so in order to do that, there is a dedicated node for this process in Nuke called vector blur. Vector blur. And so in here, it runs on the GPU. There's a couple options, and pretty much what it needs to work is the UV channel data. So if we come in here and Actually, I think I missed adding it now that I look at it. Yeah, I think I actually didn't add the AOV. Huh. Did I forget to put it on? Specular. Oh no, it's on. It's just called V. Okay. Yeah, so how it works is you see each channel, the red and the green. You can think of this as UVs. So that this is U and this is V, and our blue is empty. And there's nothing else in any of the other channels. So what we need to do is, before we could use this data, and let's actually move our photographic exposure at the bottom, since this is a post effect basically, and let's save our comp. We need to shuffle the motion vectors into U and V coordinates, right? So from here, let's drop down another shuffle, or we could do it before if we want. But well, we'll just do it after we merged here. Let's plug this in. And we'll go up to V. And what we want to do is output this as a motion instead of RGB data. So we're going to go to other layers right here and motion. And this will give us U and V. And so we only need the red and the green. We could uncheck this. And so what we want is this to get shuffled into motion, into U and V. And so what this did is it took our V attributes, the R and G, which is the UV channels, and shuffled it into a new motion channel. And so if we come up here and we look at our channel list, we should have motion. Here we go. And so it's the same data, but now it's only the R and the G channels. And so now that we've got this, let's go back to our RGBA so we can see our beauty. And we've got our vector blur here. We're going to plug that in. And actually wrong vector node. Vector blur V. Wait a second. No. That's not it. Oh, there we go. Vector blur filter. Picked the wrong one. I confuse them sometimes because there's two that look the same. So anyways, yeah, this one you'll know because it has your GPU. And so this one has UV channel options and stuff. And so what we need to do is, for our UV channels, we just need to feed it the motion. And so red, green, UV. And for our MV presets, our motion vector preset, Redshift uses the same setup as Arnold. So hit that, and it's good to go. It might not look like there's anything going on yet, and the only reason is because our motion amount is at 0. So if we start to increase this value, you'll notice we start getting motion blur. So if we move this to a smaller value, you'll see that we're getting motion blur on our object's rotation. See that? Nice motion blur. And we're also getting motion blur as we spin around. So if I were to just cache this out real quick. Yeah, we get that. Obviously, it's only 10 frames, so it's not a lot, but let's do a motion blur of 2. And you could adjust, all these settings are basically the same settings that are available in our Redshift motion blur options. So the fall off, the shutter offset, you usually want this at 0.5. What this is basically at 24 frames per second, which is standard cinema film frames per second. The half of that will be 180 degrees, which is the perfect motion blur scale that you want for 24 frames per second. And yeah, so let's, that's all you got to do to get motion vectors to work. It's pretty straightforward. See, and it looks good. I think a lot of people have problems with motion blur and motion vectors is because they don't output the raw data, which is really important to output raw vectors. This gives you, and it has to be in an EXR. This is what we were talking about earlier, that the raw data values, if we go to motion here and we just look in here, you'll notice down here the values changing. And so we're getting 40s and 30s and values that are in the 5s and 8s and 10s. And so those numbers can't be made in a non-EXR file. And then we get negative numbers. See that? Negative 10, negative 11, 12. Hue of 22, negative 9 or 10 for our value. These type of numbers aren't possible in files that aren't EXRs. They either get clamped into 0 to 1 space like PNGs and stuff like that, or they can't do negative numbers. Only OpenEXRs and EXRs in general can only do negative values. So that's why it's really important, guys, that you stick to EXRs and you output the raw vectors, and motion blur will work, no problem. And it looks, it looks good. Cool. So now we've got the beauty put together. We've got motion vectors, and we've got our tone mapping using the Redshift photographic, or we could switch to a filmic or whatever, right? And it's all good to go. Nice. So now we got to move on to our next set of AOVs. And these AOVs are more of a utility AOVs, and so I'll be going over them. I'll go over the Z depth next, since that one's kind of easy also to explain. So let's go back to Houdini, and I'll kind of discuss it a little bit. So let's come up here, and let's add the filter, the diffuse filter, because I deleted it on accident. Where is it? Diffuse filter. Let's add, where is it? Z depth. And so just like the motion vectors, you want to output the full data set. Depth mode. A lot of people use normalized because they can't see anything in their AOV. They load it up thinking there's no data there, and that's not true. The reason it is is that you can't see the data is because the values are world scale. So if your values are past 0 or 1, you're not going to see anything in Photoshop or something like that if you just load it up. And so people use normalized. But if you want accurate results in compositing, you want to use the full regular Z and the full data. And you could use the camera near and far values or not. And so this is how I like to use Z depth. It gives me the raw values, just like motion vectors up here gives you the raw vectors. All right, so that's something else to keep in mind. And let's add a couple more of these. And we're going to add, where is normal? Normals. And we're going to add object position. And these two are really important for compositing in Nuke. I'm not sure if Fusion lets you do what I'm going to show you guys in a bit, but I know that in Nuke, this is kind of like a way of making a poor man's deep pass. So, cool. Let's render out a frame, and I'll show you guys. And actually, let's bring in CryptoMat too while we're at it. And I'll talk about custom AOVs and puzzle mats and deep at the very end. And how to get an ambient occlusion using custom AOVs and stuff, since people ask about it and get confused all the time. Where is Crypto? There it is. And for CryptoMat, the settings, I have a whole video dedicated to how these each work, but I'll briefly go over it. Node name, let's actually pin this. So how node name works is CryptoMat uses the names of each of these nodes. So Platonic Object 6, Platonic Object, etc., etc. It's going to use those nodes names. The material name mode will use the name of your materials. So incandescent 1, anything with metal, anything with plastic, anything with glass. And that's the way that the naming convention will be used inside of Nuke, or the whatever app you're using for CryptoMat. Object ID will use the object ID. If let's unpin that for a second. If we come under Redshift, we have this object ID number. So it'll use whatever number you add. So 1, 2, 3, 4, 5, and so on. And then finally, the custom name ID, that will use the CryptoMat ID name that we provide here. So if we call this, spinning, since that's our spinning object, that's what will come up in CryptoMat, and it'll give this object its own CryptoMat. For our scene, I think we'll just use object ID, since each object is its own thing, or node name, and that's good enough. And for the depth, you can think of this as if we had how many layers deep of objects with motion blur in front of them should we calculate. 8 is pretty deep. I think we'll be fine with 4, since we don't have a lot of overlapping objects. I don't think actually any of them overlap, come to think of it. Or, yeah, they do right here a little bit. But that's it. So 4 is enough. And CryptoMat uses deep data. So it is the slowest AOV to render, just so you guys know. So if you don't need it, it might be a good idea to not render with it. And for normals, people get confused with why their normal AOV looks different from V-Ray's. And so I'll explain how to make a V-Ray style normal map later using custom AOVs. And the reason is because V-Ray uses, I believe, object space normals, while Redshift uses world space normals. And you could actually remap this on your own, but you know, I'll talk about that once we talk about normals in a little while. So cool, let's render this, and I'll move on to explaining how to use Z-depth in Nuke, and then how to use the crypto mat. So let's fire off a render. And actually, yeah, let's just do a still. And come to think of it, I should have done the middle of a frame. So let's do frame 5 or something. And let's let that render. And I think it's resizing. So let's go to IPR. Let's disable the half IPR size. We'll let that render. Just to make sure our AOVs look alright. And so we've got diffuse filter, okay. Our velocity. Our Z depth, you see it's pure white, and so a lot of people get confused as to why it's like this. And like I said, the data is there. So if we go to pixels and you roll you start clicking around, you'll notice that there's numbers in here. And if we come down, and I think CryptoMat's writing out, which can take a second. There we go. And we come down here, you'll notice at Z that we have different values in here. 49%, or not percent, but 49, which is a large value. Way past 0 to 1 space, you know, that Photoshop and stuff like that can handle. And so what's going on is that our monitor can't display anything past 1, which is pure white. So if I come up here to our color controls, for example, and wow, it's still way beyond what we could represent. So we'd have to do it in Photoshop or something so I could show you what I mean. Because it looks like, yeah, the values are just way past 0 to 1 space. And actually I should disable the photographic exposure before we save this. Bloom glare, the rest is okay. And let's save this out. Let's check the normals. Normals look okay. Object position looks okay. Crypto mat also looks okay. Not entirely sure what this is. I'll have to report this to the devs because I'm kind of confused what's going on right there. And yeah. Alright, so we're back in Nuke. And the file rendered out with the CryptoMat. I just did frame 6 only. I think at the end I'll batch render all of them so we could check out everything we did in 10 frame motion. But so yeah, let's load up frame 6 on its own. Uncheck sequences, and there's frame 6. And we've got the same data, so no problem there. It's just stuck on frame 6. So if we come into our vector blur, for example, and we disable it, you know, you can see what's going on. And we'll actually disable it so we can see the Z depth edits a little better. And we'll bring in our crypto map. So let's drag and drop that in. And right now it's all black. You guys got to install the crypto map plugin. Click that, and here we go. Got our masks, or our channels, I should say, that we could use as masks. So I'll talk about this a little more later. But for now, let's stick to our, our beauty here. And so let's move this over. We've got a couple different channels that we didn't have before. We've got our normals. And should have our position. Oh yeah, here we go. Our position. We've also got our diffuse filter this time, so I can show you guys how to put that together. But it's essentially the same process as we had earlier. So instead of using this diffuse, it's going to be diffuse filter. And then we just add our diffuse raw and our GI raw, and then we would just disable the GI. So just so you guys can see how that works, let's actually do that real quick. So under diffuse, instead of loading a regular diffuse, we're going to load our diffuse filter. And we're going to copy this fog since it's already here. And we're going to add our diffuse raw. And we'll call this diffuse raw. And we're also going to add, down here, our GI raw. And we're going to just plug all these in. And we have to disable our regular GI, I believe. Wait, diffuse raw. Diffuse filter. Or fog. Diffuse raw. GI raw. Yeah, and something is changing here that is not right. Got GI. And actually this should be volume. Caustics, fog emission, refraction, specular. Let's disable this grade on the specular. And what is going on here? Do I have to? This is multiplied on top of the diffuse filter. Yeah, it should be correct. Something weird's going on here. Not entirely sure what's causing it. Because this is correct. Seems like something's wrong with my GI raw. So whatever, but the idea is the same. So we've got the fog and the diffuse raw. being multiplied on top of the diffuse filter. And then that gets added over. So yeah, where were we? But it's the same idea. Basically, in Photoshop, it's multiply the filter with the raws, and then add on top everything else that isn't filter. And what we were going to work on was Z-depth, I believe. Let's see, where is that? Not... Oh, there we go. Depth. And so it looks like there's nothing in here. And if we come up here and we adjust our f-stop, you'll notice we start to get a little bit of that data right there. And so the point is that that data is there. It's just using really large world scale values, which is what we want though, because that means it's accurate. So if we come in here and we use a depth, because we can use Z-depth for several things, for adding fog or for defocus. So let's actually do defocus. And so what we got to do is use the Z-depth node, or a Z defocus, I should say. So Z defocus filter, bring this down, drop this in, and you'll notice it does something as soon as I plugged it in. It blurred everything. And so what we want is the depth channel. It's already automatically reading the depth. And for the math, there's different ways you could approach this. Since we're using the direct numbers, I prefer to use direct. And what that means is we have this focal point here, right? So you can drag this around. Let's just leave it right here. And so what this means is that wherever this focal point is, we'll basically be picking our focus, right? So we come over here, click that. And so how we adjust the strength of it is using the depth of field slider. So 0 is super strong, while something like 10 will bring back into focus more of our shot. Come up here and drop it here. You see? And I mean, the accuracy and quality is really nice. If you come around and look at the depth of field. And you could use different bokeh effect. You could use disk, bladed, or an image. Same thing like Photoshop. I mean, not Photoshop. Redshifts options, you know, where we had different bokeh shapes. So we have 5 blades, the roundness, the rotation, and so on. Let's see. If we come in here, you can see the... Right now we have 5 blades, so we've got 5 blades on our bokeh. And there's plugins that do a really good job at this for Nuke, but I think for most purposes, this is the default Z defocus works really well. Cool. So let's actually bring this back into focus a bit more. Let's try 10. Maybe a little more. 15. 20. Yeah, I think 20 is cool. So we've got some sharpness going on, and the background kind of blurs out. maybe 25. Nice. And you guys could see what's going on if you come up to the output. If you switch from result to focal plane setup, this kind of lets you see where your focus planes are. So this green is what's going to be sharp, and blue kind of represents where the fall off is going to begin as the objects go further from the camera. Nice. So now we could actually come back in and turn on the motion blur. And now we've got motion blur on top of also our depth of field. Though keep in mind when doing that there are chances you'll get artifacts the stronger you push the motion blur. So try to do a balance of the two. It's generally considered a good idea. And let's plug that in. And bring back our filmic tone mapping. So I think right now our motion blur is a little too strong, that it's starting to cause issues and tear. So you can maybe move down to 1. And we're still getting a little bit of tearing, likely due from the ZD focus. So keep that in mind, that when you start combining these two effects, you will get the occasional edge issues, and that's just something to be aware of. So sometimes some people prefer to render and bake in the motion blur, or bake in the depth of field, and then they'll adjust it in comp, one or the other, instead of baking in both or leaving both for comp, since it could give you issues. For the depth of field, let's try 30. Let's see if we can get rid of some of this edge tearing. Yeah, it's too much. And actually, the problem is with the vector blur on the edges here. I think the object's spinning a little too fast. And yeah, as you can see, it starts to give us this aliasing. So keep Gaussian. Yeah, so you can see in the UVs it starts to break. And that's just, you can only get so far with some of these tricks. It's usually good enough for stuff that isn't moving too fast. Once things start to move too fast, they'll tend to break. So that's why we're having issues with this object, because it's spinning, really fast, and it's only one frame. It might not be noticeable in the animation though, so we'll see later. But cool. We've got our render. And yeah, you know, you could try to tweak it and adjust it, but cool. Either way, so now we've got motion blur and depth of field. And we didn't have to render it in. And, you know, the results are still pretty good. They're pretty convincing overall for 720p at this res. Yeah, it might work in the animation. Cool. Let's save this out. And so now you guys know how to use Z to focus and vector blur. And those the associated AOVs. We could also use the Z depth to add grading or atmospheric haze, stuff like that in comp. And so to do that, and use that for adding fog or haze or whatever, basically we just need to shuffle out that data. So we'll plug this in here. Well, I mean, we don't really have to. We could just pull from this shuffle also, but let's just do it this way for now. So we'll get the depth. So here's our depth, our Z depth. And what we need to do now is merge our Z depth. So let's go to merge. And let's visualize our merge here. And actually let's reverse this so that it's our Z depth on top. And let's clear our tools. And let's just do it to plus. And let's drop a grade node right after this shuffle. And so if we control our multiply here, you can make adjustments. Now, we could tweak it like this. So let's just do over. So you could get a better idea of what's happening. So if we, for example, let's drop our multiply down. Increase our white and black point. Let's maybe bring down our lift. Let's just say something like this. Maybe we'll increase our multiply just a bit. So something like this. Let's say we're satisfied here. And we'll go back to plus. We've got our fog. And obviously you guys can come in here and tweak things further and, you know, really play with how strong you want the fog to be and how harsh of a fall off and all that stuff. And yeah, you guys could, you know, play around with this forever. And then we'll just merge that back in down this way. And here we are. So now we've got our motion blur, our Z depth. And this is actually our tone mapping. We could disable that for now. And yeah, now we've got multiple effects going on. We've got our fog, our Z depth for depth of field, because you can see things are getting blurrier. We've Got our motion blur on our objects. And we've got a little bit of fog. And I think the fog's a little too strong for my taste, so I'm going to just lower the mix. And that's way too much. Let's do 0.6. Cool. So let's save this. So now we've used a couple data nodes. Let's move on to one of the less known setups and what these nodes are for. The normal node and the object position or world position node. And so those are used to make kind of like a fake deep point cloud. And so let's do that now. And so what those two nodes are for, the normal and position, is for the position to points node. And so what does this node do? Well, let's shuffle, and actually let's move it this way. Let's shuffle out some more stuff. Let's move this down. Let's move this to the side. Let's drop another shuffle. And actually, we want that still connected here. What we're going to do, and we could do it further up. We probably should, but that's fine. Let's switch this over to normals. Let's just call this N. Let's copy, paste that down. Let's connect that also. And we'll call this position. Where is OP, which is position. And oops, I did not name this correctly. So normal N. Okay. So what this node does is first you connect your beauty. And you'll get another connection that'll come out, and it's kind of weird that it's kind of hard to see, but once you connect your beauty in, you'll get this other option, POS, and that's position. And then you'll get another option, which is norm. Right? And so if we look at this, this is what we get. So in the 3D view, if you hit tab, and so this is kind of like a, I guess like a ghetto deep. And actually it'd be better if we didn't use the beauty with the fog. So let's use a different beauty. Let's use the original beauty. There we go. So you can kind of see it a little better. And so this lets you make a poor man's deep data. So you can lay down assets in 3D inside of Nuke. And so, yeah, this, if we move around, our camera views something like this. And there's something weird going on actually with the data here. Since the points objects are actually stacked on top of each other, so come over here. Yeah, that's odd. Normal position. And I believe it's because our normal is using the normal map that we're the negative values and stuff like that instead of the standard V-Ray type normal map. And so I'm actually going to show you guys how to make that type of normal map instead of the one that we normally have. So if we hit tab here, and actually we don't have a scene camera, so I'd have to export the camera from Houdini using FBX and load it in, and it would line up appropriately. But obviously something's not right here because our objects aren't in the right places. So to get to that, we need to make a different kind of normal map. So we're going to head back to Houdini, and I'll show you guys how to use custom AOVs to make custom AOVs that basically don't exist in Redshift by default. So we'll be moving on to that next, and then we'll come back to this and how to use this data. Hey guys, I'm back, and actually just realized I made a mistake. So I made the wrong AOV. I sometimes confuse them. The position, object position AOV is not what we wanted. What we wanted is the world position. So if we jump into Houdini here, and we come up to AOVs, what we needed was world position, not object position. And that's why in Nuke this wasn't looking right. I was wondering why it wasn't working right. So now if we check our normal and we check our position, and actually this isn't position, this is OP, we need P. This is what we needed. And so you could split it like this, or if you do the position 2 points, and you could just plug in the color here. Let's do it before we added the Z depth fog. So if we do it here, we connect our color, and you could either connect your positions this way, and actually no, this is the wrong one. Again, position 2 points. This, yeah, this is it. So let's connect our color here, and so you could either plug in the position like this, or if you guys don't want to make extra nodes, you could just go to surface point and surface normal and choose the data that way if you don't want to shuffle it out. So if we select normal and we select P for position, this time, here we go, we've got our points correct. So if you look at it, you'll notice that we've got our render here, and for some reason it's mirrored, which is kind of weird. And I'm guessing that might just be due to the camera or something like that. Let's check here just to be sure. And yeah, that's kind of strange that it's mirrored. Let me come up here, and it's not mirrored here. So it looks like the data somehow got mirrored. somewhere, which is kind of strange. So let's actually that's a 2D operation, so it might not work, but and it did not. So I don't know why it's reversed our points. That doesn't make sense to me. Surface normal's position, yep. It should be fine. I'm gonna actually test out a shuffle because that is pretty weird. Let's do that. Let's connect our position. Yeah, and it's for some reason in 3D it's it's representing it reversed, which I'm not entirely sure why it's doing that. Normal. That is strange. But yeah, you guys, I think you guys could see now what's going on here. How we could use this to basically in 3D space and Nuke put something down and reintroduce it with a render cam back in. So we'll need to export an Alembic camera or a FBX camera. And actually, let's just do that right now. Let's come up to here. Object, find our render cam. And we're going to export this camera out. And let's export. We could do Alembic or FBX. Let's try Alembic, and we'll just call this render cam. And we should do the frame range. So we'll do the frame range. And we only want the camera. And this should be okay. So let's write that out and let's see if it wrote out. And our camera, render cam, I had to rename it to ABC. For some reason it didn't save with Alembic. And so here we've got our scene again, right? And all we got to do is bring that camera in. So let's drop down a camera. And so this is just going to be on the 3D side of things, so I should probably move it to the side a bit, including all this stuff. And actually we'll just delete these just to keep our node graph a little simpler. Let's load this up. Actually delete everything. Load this up. And let's unhook everything and just hook our beauty. There we go. And let's load up our camera. Let's go to read from file. We're going to come in here and there's our render cam ABC. Just say yes, destroy all the data on it. And that should give us our camera. Let's camera 1. Let's see. Yep, it's rotating. Cool. But the problem is our points are being generated incorrectly. And I'm just guessing it's just the format that Redshift writes it as. And so to fix this, we actually need to just transform the points. So let's first drop down a scanline render so you guys could see kind of what the result is. So let's plug in our camera and our scene, and let's drop down a reformat node. And we'll make this 720p. And let's check out the result. So this is our render here using these points, and obviously it's flipped. So in order to fix that, you could do a transform 3D, and let's drop that in after our points. What's going on? Why is it not 3D? Transform geo. Wrong transform. Okay, here we go. With the transform geo, and this lets you kind of rotate stuff around. And so let's see which way it's going. And actually, let's view it in 3D view since it's faster. Let's come up to this level. So that's the translation. So let's make this 0. So a little trick that everybody knows is you can flip the scale. So we're going to make this -1, and there we go. Now our world space data is correct. And so that's flipping our position, our world position, and our normals. So let's come back down to our format node, and here we go. Now we've got this. Now the idea behind this is you wouldn't actually render the points, because you can see, their points, they're not accurate. What it's for is placing cards or assets like that. So what do I mean by that? We could use this data to basically position a card into 3D space. So let's say you had smoke, or I don't know, whatever, right? Like whatever asset you need to blend in here, you could place it that way. So if we start dropping down 3D geometry, and yeah, let's just do a card, and we'll do checker. Oops. Checkerboard image. And let's move this to the side here. And let's do 3D merge. Can't remember the name. Or a scene, I should say. And merge our card in. And let's check out the scene. And where is our card? Our card's right here. Let's select that. And let's just move it somewhere. Into position. And what we want to do for our position to points is we actually just want to display it but we don't want to render it. So we're going to turn that off so it doesn't render. So if we come back to our format, you'll notice that now we've got our card here. And so what we could do, which is pretty neat, is merge this back over on top of our base render here. So we connect that and connect our base render again. And is our order right? There we go. You see, we come in here, you'll notice that our card that we made earlier, and let's actually tweak the make this 200. You'll notice that our card now, we could completely edit where it is, the size, the rotation, and so on. So we can make this, let's make it larger, and it blends in to where we have it, which is really, really powerful. So this makes it easy. If you want, let's hit tab. If you wanted to, I don't know, put some fire on a torch or something in your scene, let's move it back this way. Let's rotate it a little bit. Let's do 25, 60. And if we hit tab again, you'll notice it's right where we want it. And so if we were to rotate around, right now it's not going to look right because our background is only one static frame, but you'll notice as we move, the card, the perspective and everything will be 100% accurate. So it'll be like this, and it'll match. So really powerful tool to do things this way, as this lets you, using the normal and world position AOVs, lets you build this point cloud, which then lets you place in compositing 2D assets inside your scene. And you could also relight using the normals and stuff like that, but since we have now in Redshift per light AOVs, it's kind of a little more useful for that task to do it that way. So yeah, cool. So let's save this. And actually, let's see what happens. We come down here and just see what we get. As a result, and actually we're losing our data, which explains what's going on here. Our channels aren't carrying over. Or actually, no, what's wrong is it's the mask is what's connected. So let's rehook that. And there we go. So we've got, I mean, the motion blur is not perfect, but we've got somewhat been able to blend that in. And that's without using any 3D modeling. So this is useful if you need to composite smaller effects like smoke or something in your 3D scene, and your smoke is a 2D asset. You could just put it on a card, move the card into position, and everything will work out okay. So if I, for example, move the card further away, it'll actually be influenced by the depth of field, see? So now it's blurrier. So really cool, really powerful AOVs that a lot of people don't know about or use. Now, whether you can use that in Fusion, I'm not 100% sure, guys. I don't use Fusion, don't know it. But I'm sure they have something similar. I I don't doubt it. So as you can see, you could kind of move things around, which is great. Really useful. Obviously, it's not in the reflections and stuff like that, but I think you guys get the idea of what it's for and what it can do. Cool. And so yeah, this lets you kind of just merge in assets that you know might needed to add in later or 2D and didn't have time, or changes needed to happen. So yeah, let's move on. So we've covered the normal map, the world position AOV, the vector motion vectors, the Z depth for both depth of field and fog. We've covered how to composite everything. So the only things we really got left are Cryptomat and I believe how to make a couple custom AOVs and a couple masks, so different mats, and how to make a clown mat, which is kind of like a poor man's crypto mat, since some of you guys asked about how to use that in Photoshop, and we could do that with attributes. So yeah, cool. So yeah, we're gonna come back into Houdini, and I'm gonna talk about those last few AOVs, and we'll be moving on back into Nuke at the end. All right, be back.